Hello, dear students. Today we have Proposition 1 of Book 3. We're entering Book 3. Book 3 is about circles. We should have had our meeting today going over the definitions of circles. They're fairly easy, but if you have any questions, please send me a message or to one of your assistants. Send a message for the question, okay? Today's proposition: to find the center of a circle. Here's a circle, thus it is required to find its center. Seems impossible, right? Is it here? Is it here? I don't know, let's measure. But remember, Euclid's not about measuring, it's about the intellect. So let's just use our intellect here, okay? So, why don't we draw a line from one point to another, okay, of the circumference of the circle. Okay, now in our bag of knowledge, we know that we can bisect a given line. We also know we can draw a line at right angles to another line. We've proven that. And then we're going to use today side, side, side also. If two sides are equal to two sides and the base equal to the base, the angle those two sides contain are equal. Okay, so let's tell you in advance what we're going to do. So right now, let's bisect this line. We know we can do that. We've proved it in the past with a quod erat faciendum. Now, we also know with a quod erat faciendum that given a line, from a point on that line, we can draw a line perpendicular to it. So let's do that right now. Boom, and then continue it the other direction. Great. Now with this line, let's bisect it. We're not measuring. We know we can bisect the line. We've proven it. Given a line, to bisect the line. Great. Now I say that we just found the center of that circle. Easy, right? We found it. Done. No, Mr. Smarty Pants says, I don't see that. Why don't you prove it to me? And I can't prove it to him right now directly, so guess what we're going to use? A reductio ad absurdum. Remember now, a reductio ad absurdum is you say one thing, and Mr. Smarty Pants says no. So you say, okay, Mr. Smarty Pants, let's say you're right. In this case, you say that A is not equal to B, and he says, no, I say it's equal to B. Okay, Mr. Smarty Pants. And then you take other things that you bring together. Well, you and Mr. Smarty Pants agree that B equals C, say. So if A equals B and B equals C, therefore, that little triangle thing, A equals C. Great, but we already know that A is the whole and say C is the part, and the part is not equal to the whole. So here we have A equals C and A is not equal to C. That's called the reductio ad absurdum, that something can both be and not be. That's ridiculous. We might not see that this is ridiculous, but we see that that's ridiculous, that something cannot both be and not be. Let's do that, Mr. Smarty Pants. And we'll start off over here. If this is not the center, we know that every circle has its center. So let's say any position you want. You want that position, Mr. Smarty Pants? You want that one, doesn't matter. Whatever you say, I'm going to reduce it to an absurdity. Ready? Here we go. Let it be that one. Are you happy, Mr. Smarty Pants? All right. Let's connect some lines. These 2 points, let's connect some points, sorry. And from this point and this point, make a connection. And from this point and this point, make a connection. So remember, Mr. Smarty Pants, you're saying that's the center of the circle. And we know from the center of the circle, lines drop to the circumference are all equal because they're radii of the same circle. Radius of this circle, if that's the center. But it doesn't look equal. I know, Mr. Smarty Pants, we're already having problems with the imagination because you're asking me to hold something that's false. This is going to be false if that's the center. I'll show you. Now, we know that this is equal to this because we cut this line in two. We bisect it, so this equals this. And in these two triangles, we have this being equal to this and this being equal to this. This triangle and this triangle have two sides equal to two sides. And the base being equal to the base because they're radii of the same circle, according to Mr. Smarty Pants. Therefore, the angles that those two equal sides contain are equal. We've proven that in side, 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 remember? Two triangles, two sides equal to two sides, and the base equal to the base. The angles which those two sides contain are equal. We've proven that. So let's show then. Okay, so here we got this being equal to, say, this. Okay? But remember now, and we know that in two if a line be set up on a line, creating adjacent angles equal, those two angles will themselves be right angles. We've shown that in the past, okay? So a straight line falling upon a straight line creates either two right angles or two angles equal to two right angles. So this and this are, let me think here for a second. Is going to create two angles. Yeah, if this equals this, and they're both equal to two right angles, this and this are each a right angle, because when a straight line falls upon a straight line, it creates the adjacent angles equal to two right angles. And we know then that this and this are equal to two right angles, but they're also equal to each other. So they both must equal one right angle. Great. But now remember, we originally set this line on this line at right angles. Okay? So this equals this. Well, if this equals this and this, if these and these are both right angles, that means that here we have a right angle and here we have something as a right angle as well. Remember, we've proven that this is equal to this, and they're equal to two right angles, so this and this are each a right angle. So this is a right angle and this is a right angle. Therefore, they're equal to each other. So this whole angle is equal to the part being equal to the whole. Okay, so we got this being equal to this, but we know that the part is less than the whole, so this is unequal to this. So here we have that situation in reductio ad absurdum, that it's both equal and unequal. If we get to this point, the absurdity, we know that the thing we granted in the beginning must be false, because everything else that we pulled in was true. So if we have a logical argument and it leads to a conclusion that is absurd, there's something in our argument which is false. So the only thing that could be false here is that this is the center. Likewise, if we go over here and do the same order, with this being the center, we're going to have the same problem. That something is both equal and not equal to something at the same time in the same respect. Equal and not equal. So that's false. It cannot be the center of the circle. This cannot be the center of the circle. This cannot be. The only place where you're not going to find this absurdity, Mr. Smarty Pants, with that being the center of the circle. Therefore, what we showed in the beginning, that having bisected this, drawing perpendicular, and bisecting this, that point of bisection is necessary the center of the circle. Okay, so we found the center of a given circle. Quod erat faciendum. Thank you. Bye-bye.